Hello everyone. Now what we are discussing in this is a 4 by 2 spool wall. In the position 1, the spool is connected to P to A and the port B to T. This allows the pressure from P to A while the return flow from B to T. In the position 2, the spool is connected to P to B and the port A to T. This allows the pressure flow from P to B while the return from A to T. See, such walls are used, which is called as the double acting cylinders. The schematic diagram shows the 4 by 2 spool wall. See, here in this case, the horizontal member, which is something like a stepper shaft, is called as a spool. The spool movement is actuated either by means of the manually or by mechanical or by means of lever or by means of solenoid. As the spool starts moving from left to right, the port T to A is under open position. Once if the T to A is under open position, the fluid which has been actuated and as well as where the work has been extracted, that it will flows backward from A to T, and then it will be passed to the tank, or it may be the reservoir. The same way, if the spool moves from right to left, it is blocking the port A, and as well as it is opening the port B. From B to T, it is open. The fluid which is used for the application purpose, that it will be drained back to the T, and through the T it will be passed to the tank, or it may be the reservoir. But here in the first case, P to B is open position, where the pressurizing is done from the port P to B. The same way in the second case, where the pressurizing is done from the port P to A. Like that, the opening and as well as the closing of the port, it can be done very easily. Here in this case, the four ports are there: P, T, A, and as well as B, and 2A. 4 port and as well as a 2-way. For that reason only, it is nothing but 4 bar 2 spools mechanism. The next one what we are discussing is nothing but the rotary wall. The rotary wall consisting of the rotating spool, which aligns with the hole in the wall casing to gives the required operation. The figure shows the construction and as well as a symbolic representation, and the typical wall with a center of the action. The rotary wall are compacted, are very simple, and have a low operating forces. They are, however, the low pressure devices and are consequently used for the hand operation in the case of the pneumatic systems. See, this is a schematic diagram shows the rotary wall. There are 3 sketches is there. The first one is representing where the P to A and as well as R to B, it is both are in open position. Once inner what we can say, the rotary wall which has been rotated, it is blocking it P to, where the flow it is taking place from P to B and R to A. Just by blocking, or it may just by rotating the what we can say, the rotor, it is converting the flow from P to A and as well as R to A. The same way, still further rotation of the rotor, it is opening or even the closing of all the walls, it takes place. Once if there is a closing with respect to all the walls, automatically the entire system will be in the shut off condition. See, this the control, it is done by using the rotation of the rotor in the stationary casing. This type of walls normally is having a major application in the pneumatic systems. The symbolical representation of the rotary wall is as shown in the figure. The next topic what we are discussing is nothing but a solenoid actuated wall. The very common way of the actuation of the spool walls is by means of the solenoids, where the electrical coil is energized. It creates a magnetic force that pushes the armatures. This causes the armature to push on and the push the pin to move the spool of the wall. Like the mechanical or it may be the pilot actuators or the solenoid valve works against the push pin, which is a seal to prevent the external leakage of the oil. There are two ways of the solenoid design used for the dissipating the heat created by the electrical current flowing in the wire or of the coil. The first type is simply dissipating the heat to the surrounding air and referred to as the air gap solenoid systems. The second one is nothing but the pin type solenoid or the push pin contains the internal passageway that allows the tank port oil to communicate between the housing of the wall and the housing of the solenoid. A wet pin solenoid do the better job and dissipating the heat because of the cool oil represents the good heat sink and absorbs the heat from the solenoid. As the oil circulates, the heat is carried into the hydraulic system where it can be easily dealt with. The fluid around the armature serves as a cooling and it also acts as cushioning and it strokes without the appreciable affecting the response step. This one is nothing but the oil cooled or the oil gap solenoids. Uh, there are no ceiling around this armature to where the restricts its movement. This allows the power development by the solenoid and to transmit to the wall spool without having a overcome in the seal friction. The impact load frequently causes the premature solenoid failure or the elimination with the construction. See, the schematic diagram shows the solenoid controlled spool wall. The solenoid consists of the armature and as well as the coil. Once if the coil is energized, the movement of the armature is taking place. The movement of the armature is from the left to right. It is forces the pin for the movement of the spool. Once if the spool is moved, it is moving from left to right. In the same way the pin or the push pin which is there to the right side, where once if that coil is energized, automatically the armature will starts moving from right to left. Automatically it is pressurizing the push pin and moves the spool to the left side. The symbolic representation is represented and it is shown in the figure, which consists of both the ends is represented by means of the solenoid only. The next topic what we are discussing is with respect to the pressure control valve. The hydraulic energy is produced as long as the prime mover drives the pump and the hydraulic pressure develops by the resistance of the pump flow. Hence, the hydraulic system suffers a damage if the pump flow is not stopped or offload or the back to the tank during the non-action period circuit. A non-action period arises from the stalling an actuator or by reaching the end of the stroke or the circuit sequences or during the time delay period of the circuit sequences. In order to avoid the hydraulic system damage, the power wastage and as well as the overheating of the hydraulic fluid circuits, the designers uses a variety of a clearly designed system to control the maximum system pressure and the pump flow during the non-action periods. The pressure control valves are used in the hydraulic systems to control and to actuation forces, which is nothing but force is equal to pressure into A, which determines and as well as the selects the pressure level at which the certain machine operates and must occurs. The pressure control valves are mainly used to perform the following system functions. The first one is limiting the maximum system pressure at the safe level. The second one is regulating and as well as reducing the pressure in certain portions of the circuits. The third one is unloading the system pressure or the releasing the system pressure. The fourth one is assisting a sequential operation of the actuator in a circuit with a pressure control. The fifth one is any other pressure related functions by the virtue of the pressure control. The sixth one is reducing or stepping down the pressure levels from the main circuit or to lower the pressure in the sub circuits. The pressure control valves are often difficult to identify, the mainly because of many descriptive names and given for them. The function of the valve in the circuit usually becomes the basics for the name. The valves are used to accomplish the above mentioned system functions, are therefore it is given as either it may be pressure relief valves or pressure reducing valve or pressure uploading valve or counterbalancing valve, pressure sequence valve or braking valve. The first what we are discussing is nothing but the pressure relief valve. The pressure relief valve limits the maximum pressure in the hydraulic circuits by providing an alternate path of the fluid flow when the pressure reaches to a preset level. All the fixed volume pumps and as well as the circuits requires the relief valve to protect the system from the excess pressure. A simple pressure relief valve is explained now. The most widely and as well as a type of the pressure control valve in the pressure relief valve, because it is found a practically every hydraulic system. The schematic diagram of the simple pressure valve is as shown in the next slide, and it is normally a closed valve whose function is to limit the pressure to a specific maximum value by diverting the pump flow back to the tank. The puppet is held seated inside the valve with a heavy spring. When the system pressure reaches to a high enough, the puppet forces off its seats. This permits the flow through the outlet to the tank, and as long as a high pressure level is maintained. The schematic diagram shows the pressure relief valve, the simple pressure relief valve. The left part is nothing but the pressure port, and the right part is nothing but the adjustable screw where the spring pressure is applying over the puppet. Once if the pressure is reached to a maximum, automatically the pressure pushes the puppet against the spring pressure, and automatically the fluid flow, and the same thing it is moving into the tank port. Once if the pressure is dropped, automatically the puppet will closes because of the spring pressure, and the tank port it will be in the closed position, and the fluid flow from the pressure port to the tank port is stopped.